It gets a little bit more serious with my talk, but not that serious. So I promise, try to keep it fun for everybody. Like Leonel said, one of the beautiful things about something like OpenTelemetry, spoiler alert, I used to, in my previous life, work at an observability company and actually contributed to co-founding OpenTelemetry. So open anything is really great. So that's going to be part of my talk today, is talking about open weight models. What are the choices you have beyond something like Claude? I think Anthropic, excellent company. For consumers, for us end users, it's really all about choice, right? Like you don't have to choose open weight models. It's good to be aware of them and what they can do. So that's kind of how I want to tie back what Momento has been doing for our media customers, for a lot of you sitting in the audience, and how we got here. So to begin with, I'm Daniela. I'm the CTO and co-founder of Momento. One of our biggest projects thus far this year is working with a lot of our media customers to support tentpole events such as the World Cup. One of the concepts that we had dreamt up earlier on last year is now reality, right? So something like this simple question that you see on the screen, no pre-built dashboards needed, no engineer trying to translate natural language into a SQL query and quickly typing it into a SQL window so that you can answer, your VP's question. They can just type it. They can express it in natural language. The LLM will interpret it, go gather the data, and answer it all in real time. So I'll walk through a few of the workflows that we've worked on with our customers, and then also one of our own workflows. So looking at what we did during the World Cup and sort of what happened with one of the scenarios with beacons, very simple. So you get these live streaming players, and the players are beaconing back to Momento. Momento Functions is this flexible runtime layer that allows customers to encode their custom business logic on how to interpret these beacons and what to do with them. So an oversimplified version of this is that we ingest and then we persist them to two places, to the Momento cache for hot data, real-time querying with low latency, and then a durable store, something like S3, where you just throw everything for offline analytics if you want to do historical queries. And then make all the data available back to the customer via an MCP server, some sort of an API server that gets you access to all the data. If you are querying something like the question on the first screen, hey, in the past 5 minutes, are there any suspicious sessions that's requesting way more than a player plausibly should, right? And it just gives you the suspicious sessions. Now, if you want to do like, okay, well, what happened during this entire month of the World Cup? What are some of the specific questions? You have to go to S3, and the agent can do that. That's pretty cool. How do we come up with all the nitty-gritties of the architecture? We used a set of questions that kind of guided us through the processes. It really comes down to who's asking the questions, who's orchestrating the request that comes out of the question, like where to send it, who's sitting in the critical path of getting you the answer, what model is answering, right? What model is thinking and reasoning through your question, and then ultimately who's serving the model, right? Who's actually running the model. A model is basically a set of inert weights, right? They're literally like numbers, right? You can store that in S3. A model doesn't do anything. It doesn't become anything. I mean, just like all of you guys, the content doesn't do anything. It's just a bunch of segments sitting in durable store. It doesn't actually become real for the users until all of you, the media streaming providers, actually serve the content over your own infrastructure. So a very similar architecture. I'll quickly just breeze through this one because Edwin already gave a very nice presentation on the architecture of the Paramount AI personalization workflow. It looks very similar to the previous one that I showed. Again, this is a 30,000-foot view. The details are different. The overall architecture is very similar. You ingest, you store it. Instead of an LLM, it's an embedding model, in this case, that indexes the content. And then you serve it back. Rank it, you provide some recommendations based on the personalization aspects of the user requesting the data. And then again, in order to come up with each segment of the architecture, you use 5 questions, you make 5 decisions. That kind of draws out the outline of your architecture. So we did that internally for Momento as well. what is an infrastructure company doing building coding agents, right? Well, we are ultimately a serverless infrastructure company that optimizes and improves the performance for our customers. And all of you are using AI now in your critical path. A lot of you are, at least. So then it becomes our responsibility, and we're being challenged to also help our customers control, tune, optimize, and just continue to improve the utilization of your infrastructure. So part of that is really requires us to dog food our own infra and really understand all the components of the system so that we can do a better job with performance, with latency, and with utilization. So building a coding agent just sort of fell out as a natural consequence of us wanting to dog food our own infrastructure, including having large language models in the critical path. So really, what did this come down to? Well, we already have a router. We have a gateway that's sort of in the critical path of serving requests of our customers, but also for our own internal usage. And we just continued building from there. We explored closed weight models, of course, Anthropic, OpenAI, but we also started looking at open weight models. For example, a lot of our internal operation processes, Bradley kind of touched upon this, whether it's observability, detection for anomalies, and then right now in production, a review bot, right? It looks at every pull request. It has very, very specific context about our coding guidelines, our coding styles, the tooling that we have internally that's not exposed on the public repos. And it knows what to do about that, knows how to review it. And it just does it automatically. It does it in a few minutes, like way faster than you would get from some of the closed weight models. And it does it at a fraction of the cost of what a commercially available product would cost if we went out and paid, whether it's GitHub Copilot or CodeRabbit for the same tooling. And it's specific to us because we built it from the ground up. So those are kind of the 5 questions that we asked ourselves in order to continuously iterate upon our own infrastructure, because that allows us to keep up with the velocities of our customers and their shipping velocity and their bar for for new feature shipping. All right, so what I'm here really to convince all of you to realize is that all of you are already AI enabled and AI infrastructure engineers by being video and media infrastructure engineers, because you've already built this once. All the jargons sound different and it makes it feel like a different domain. But really, if you look at the different layers and what we have to go through, it's the same. You've already built this. It works for millions of customers that you're serving all over the world. And it always starts with a human at the top layer. And that's all of you, the operator. Right? The AI agent, as much as it's capable and able to act autonomously, it starts with the human that built it. And that's really like the end user, right, consuming the content in the video world. There's a bit of an analogy that I'm trying to draw here. And then, of course, who orchestrates that? Well, in the coding agent case, it's the harness, right? Whether it's a Codex CLI, Gemini CLI, the Claude Code CLI. There's open source alternatives now, Open Code, PyHarness. There's a ton of them. They're the ones that actually take the request of the user or the human and initiates the request. And then you go through some sort of a gateway, the routing layer, maybe the CDN, the content delivery networks. There's entitlements, right? Where do I put you in the queue? How important are you? How much money are you paying? That kind of qualifies you for priority. The model itself. And then the inference provider who actually serves the model. In the market, sort of on LinkedIn, people talk about the model a lot. Like that's pretty much like all what I hear about generally in my professional network. And I think the model is certainly important, but we focus on it too much. And that's because it's interesting to talk about and it's difficult to understand. But really, I think the rest of it is what I want to talk about with you all today. So let's dig into it. We can start with the model, though, because as much as people talk about it too much, I don't think that we really think about it in a structured way. So we came up with this acronym. It's called PAC. It's the opposite of CAP. which is, for those of you in computer science, the CAP theorem is this classic computer science: consistency, availability, and partition tolerance. You pick 2 of the 3. It's very difficult to get all 3 in a distributed systems. And for picking a model, it's actually very similar. It's easy to pick 2 of the 3. It's very difficult for a model to achieve all 3. For sake of example, I've really simplified it down today's presentation to 2 models. You have your Claude Fable. That's kind of your state-of-the-art frontier model from Anthropic. Excellent model. And then you have your open weight alternative, it's called GLM 5.2, one of my recent favorites on the open weight scale. There's hundreds more out there, if not thousands. For the sake of comparison, I think these 2 are representative of sort of 2 ends of the spectrum. If you look at performance, accuracy, and cost efficiency of these models rated by the public benchmarks, usually there's a trade-off between all 3 of them. Right? You can pick 2 and then give up on the other one. So for GLM 5.2, the open weight model, it's super fast. Look at the bar on performance. And it's very, very cheap. Look at the bar on cost efficiency. So for the 3 bars, the higher the better. But it sacrifices accuracy. In reality, for the public benchmarks, it's about 15% less accurate and less good, quote unquote, on quality. I'll come back to what good really means. And then Fable just rocks it on accuracy. This is actually now a little outdated. I think that Opus 5 on its max reasoning is actually beating Fable. But at the time of me making the slides, which was like yesterday, Fable was still good. But today, I think Opus is better. Anyway, so this changes like literally daily. Like I had to go on the public benchmark websites this morning, and I was like, it's too late to take another screenshot. Whatever, let's keep my slides. But really, what I'm here to tell all of you, and I'm glad I think Bradley also talked about this, observability, benchmarking, automated evals, that's actually the part that really matters, right? Like, I mean, you can spend hours, days evaluating the models today, and then you can wake up next week and it's all outdated. Like at the rate that new models are coming out, it's just way too overwhelming to do it on a manual basis. So really, I think what people really ought to focus on is evaluating this on a continuous basis rather than a one-time exercise. And there's no way that humans can do this fast enough. It's extremely onerous. It takes forever to run these benchmarks, and they go stale too quickly. So I think that the best upfront investment, and this is very similar, having worked in observability, is that people do not invest enough upfront in these things. And usually by the time you realize, a bunch of problems have already come up. So I think the number 1 takeaway that I have for all of you is to just go back and ask your organization, ask your teams what you have in automated benchmarks for evaluating LLMs. Because if you're going to pick one, you might as well know why you picked it. So to sort of just dig into the numbers a little bit more, I already showed this previously. Fable is about 15% smarter according to the public benchmarks, and like 149x slower. This is measured by time to first token, which is by the time you press enter on your question, and then like it goes into a little spinner, how fast does it take for the spinner to go away, for the first word to come back? The output speed controls how quickly the response is populated after the first word comes back. And there's a huge difference here. And I think if you guys are used to using Claude Code, you will know, like when it's struggling, it will say, I don't know what it says, like discombobulating, philosophizing, it has all those like funny words that's just trying to keep you engaged while it's calculating. If you ever try an open weight model, like I said, I just love GLM 5.2. It honestly feels like it starts answering before you even ask the question. It's like very, very, very jarring how much faster it is. So that's one thing to consider. But really, what are you giving up on intelligence? Oh yeah, this is the artificial analysis. I forgot I took this screenshot. This is already outdated as of yesterday, but today it'll look a little different. If you're interested in just seeing what's out there, well, like what's the smartest model, what's the fastest model, what's the most cost-efficient model, This is just a really good site because they're like supposed to be third party, vendor neutral, and then they just run daily tests around all these providers and all these models. So that's where I got most of my numbers from. But there's something problematic about public benchmarks. For those of you that remember this whole like vehicle emissions test scandal, exactly. If you know you're being tested on something, you can prepare for it. In fact, during the vehicle emissions test, you can put your vehicle into an emissions test mode where it passes the emissions test. And then in reality, 99% of the time or 100% of the time, you will never run in that mode. Unfortunately, this happens with public benchmarks. Because the model, the authors of these models, they know that these benchmarks are what's being used to measure them. There's a lot of contamination because the models are trained on the public repos and the public open source code. So what I think is that this graph can only tell you the short list of models that you should consider for further evaluation. Because there's hundreds, thousands of models, it takes way too long to try to go through each of them. So it's a really good way to quickly filter it down because it does give you the categories of models that you should look at. But really, to make decisions for your use case, for your production, we have to build our own benchmarks, and so do you, because there's internal business logic, business tolerance, risk tolerance, styling guidelines, technical decisions that have a lot of history associated with them that these models do not have and do not know. There's internal tools, internal MCP servers, internal skills that none of these models have been exposed to or evaluated against. So it takes a little bit of, again, it's upfront investment to build your own evals on your code, on your tools, and then it gives you a much better idea of which models are better for which of your workflows. And it's actually not too hard to build the benchmarks. You can use AI to help you generate these benchmarks. But the point is that you can't just look at the public benchmarks. You have to run your own. And when we did, the results are actually quite different. I mean, it still showed us that GLM 5.2 is a cheaper model, and it's very fast, but it's not 150x faster. It's something like, what are the numbers there? Like 60% faster. And the reason is because when it's working with real code, it takes a different path, right? Real code is generally more convoluted. Production code is sometimes more less predictable than open source code. So it might actually take a different path than it does if you're a more intelligent model like Opus 4.8. So when we ran this, now we can sort of definitively say, okay, these are sorts of the tasks that we want to assign to the open weight model, and these are the other kinds of more complicated tasks that we should leave to the frontier models. So it becomes your own bar, and it's rerunnable. So one of the things that we've set up is that when new models come out, like last week, it's all about Kimi K3. So when that comes out, it's automated. By the time we wake up in the next morning, we know what Kimi K3 is better at or worse at. And TLDR, it's a pretty impressive model. All right, so coming back to after we talk about the model, we should really talk about how it's served. So for Momento internally, because we've started to adopt open weight models, primarily GLM 5.2, it really matters where you get that from. And there's different providers. We've started with 2 so far. One's Base 10 and one's Fireworks. And they have these tiers, right, where you can optimize for latency, you can optimize for cost. And then we built in our own failovers, right? Just like the outage from Claude. It's really annoying when you start getting 500s in your like review pipeline. So it automatically fails over if we get throttled, if we get internal 500s. And to the end user, they have no idea that this is all happening behind the scenes. I mean, all of you have this. Like, pretty sure nobody here runs on a single CDN, right? That's the point, is that your end user shouldn't really care about where the content is coming from. The point is that they get it in the fastest time with the best quality possible. So that's the provider aspect of it. And you can build that into your benchmark as well. You can benchmark against different providers and not only evaluate models, but evaluate providers in the same stroke. All right, moving up the stack, the gateway. What is that doing? It's centralized management, basically. It understands things like entitlements, and understands things like which providers are maybe having an outage, so it can direct traffic away from one into the other. It's where you can control all your secrets, you can redact things, you can also show budget enforcement, right? How much am I spending on each provider, and how much budget am I willing to allocate to certain teams? It's where all the visibility comes from. And that is essentially what the gateway layer is doing. And then moving up the stack again. Actually, people don't talk about this enough. I think more recently it's starting to pick up. But we're used to picking a harness from the model provider, right? You use Claude Code, and of course you use the Anthropic models. It really doesn't make any sense if you think about it, because they have very little incentive to make your harness token efficient, because guess what they charge you on? Tokens. So I think people are starting to come around and adopt a lot of the more open source standards like Open Code and Pi. It is also what, by the way, motivated us to build Mo, which is our own harness. It gives us a lot of control into the system prompt and how tokens are used and reused for the best quality and for the best performance. So actually with the same model, even if you send it to Anthropic, using a different harness will actually speed it up. And this actually surprises a lot of people. But again, it's just a matter of how much have you actually optimized your client, right? In distributed systems, everybody knows that your client can cause the whole end-to-end latency to shoot up. It's the same thing here. So it's just another thing, like similarly in video, right, where you actually ingest where you actually consume the content. Like the player matters a lot, whether you're an iPhone or like some super outdated version of Roku. Like it's gonna matter, and it'll cost more as well, depending on the device. All right, out of all the layers that I've talked about, I actually still think that, and I'm not biased, maybe I am, but I still think that we matter the most. All of you matter the most. The human matters the most. What the AI agents actually do is they amplify your judgments, whether good or bad. So I think that while the models are coming out every week and they're actually converging, a lot of their architectures are starting to look the same. I mean, it makes sense. If somebody comes up with a good technique, everybody else is going to adopt it. But I don't think that the humans are really going to converge anytime soon. We're going to continue being different. We're going to have our unique approaches and unique thoughts on how to make impact on our businesses. And then you're the ones that actually carry innovative judgments on how to affect your business's top line, how to make a product successful. So I think that it's really important for all of us to understand how the stack at least works and how the cogs all fit together, because it allows us to make good judgments against the system that we're working with underneath. And for us, we decided to start with our own engineers because it lowers the risk on our business. We're not putting it in the critical path of our customers' workflows yet, and allows us to just learn a ton, gather internal feedback, dog food our own stack, and it allowed us to iterate upon different models, to do bake-offs between different providers. We even dabbled a little bit into self-hosting models. That's like a whole nother presentation, but it's very interesting. And I think that being engineers, we should be curious about how this all works underneath the scenes. All right, final slide. We made it. We're pretty proud of it. It's now working pretty well. We're using it in production ourselves for operations and internal engineering velocity. It's definitely accelerated us when we're looking for feedback. So it's a private release today. We put it up. It's all, for now, because it's a private release, it's all free. We're really just looking for feedback. And I put the brew install, the CLI command up there. And if you want to actually try it, tomorrow, Quadra, I think in the same room, around 10 o'clock, he's running a hands-on tutorial to actually walk through coding harnesses. Not just the one that Momento built, but compared to, Codex, Cursor, Claude Code, whatever your favorite harness is, bring it. We'll run through it with you, and hopefully you can learn a few things. Thank you.